Hello, welcome to this platform. My name is Dr. VP Jusi, working in the Department of Mathematics. Today I am going to present a brief overview about differential equations. What does a differential equation means and types of differential equation? Then we will move towards order and degree of a differential equation, how we can find order and degree of a differential equation. Then solutions, what does a solution means and types of solutions. First, as the name suggests, differential equation, basically differential equation plays an important role in dealing with engineering and science problems. Many physical problems is actually formulated in the form of differential equations. Therefore, the study of differential equation is mandatory in case of engineering and science. As the name suggests, differential equation basically involves two terms. One term is differential and the second term is equation. Equation is basically anything that involves equal sign. Here equal sign involved, therefore this one is said to be an equation. Similarly, a differential equation is basically an equation in which derivative or differential coefficients are involved. In the case of derivative or in the case of differential coefficient, as you have already studied in differential calculus, suppose if y is a function of single independent variable. If we differentiate this function with respect to x, then we obtain the first order derivative, which is denoted by dy by dx, and is actually known as ordinary differential coefficient. Ordinary derivative or ordinary differential coefficient actually exist when the given system involves single independent variable only. Suppose if z is a function of two independent variables x and y, then if we differentiate this function z, then the derivative or differential coefficients are said to be partial differential coefficient. There exist two partial differential coefficient, del z over del x and del z over del y. Del z over del x is actually evaluated in the same manner as we differentiate in the case of ordinary differential coefficient, but here z function is simply differentiated with respect to x, assuming remaining variable, that is y. Y is taken as constant while obtaining del z over del x. Similarly, to obtain del z over del y, we simply differentiate z with respect to y, assuming x as constant. So differential equation is basically an equation in which differential coefficients or differential coefficient in general we find the dependent variable with respect to independent variable. So as equation 1 basically equal sign involved, and additionally the derivatives are also involved. Therefore, this is a differential equation. Similarly, second equation, again equal sign as well as the derivatives are involved. Therefore, equation 2 is also a differential equation. Similarly, third, fourth and fifth all are differential equations, since all equations have equal sign as well as the differential coefficient or derivative of the dependent variable with respect to independent variables. Now, classification of differential equations. Actually, differential equation can be classified mainly into two categories according to the derivative involves. Ordinary differential equation is actually a differential equation in which ordinary differential coefficients are involved, or equivalently we can say that a differential equation is said to be an ordinary differential equation if it involves the single independent variable. Single independent variable always yields the ordinary differential coefficient. Therefore, it is said to be ordinary differential equation. Suppose dy by dx plus 2y is equal to 4. Here in this differential equation, only single independent variable, that is x, is involved. Therefore, this equation is said to be an ordinary differential equation. Similarly, in the case of partial differential equation, a differential equation is said to be partial differential equation if it involves the partial derivatives, or partial derivatives always exist when the given function involves two or more independent variables. Suppose if we write x del z over del x plus y del z over del y is equal to 2z. Here, the partial derivative del z over del x and del z over del y are involved. Or equivalently, we can say that here z is a function of two independent variables x and y. Therefore, this equation is a partial differential equations. Now, order and degree of a differential equation. Order and degree. Order of a differential equation is basically defined as the order of the highest derivative that is present in given differential equation is said to be order of the differential equation. Suppose if we write a differential equation d cube y over dx cube plus 2 dy over dx is equal to 5. In this differential equation, this term involves first order ordinary differential coefficient, and this term involves third order differential coefficients. Therefore, highest order differential coefficient term is this term and its order is 3. Therefore, the order of this differential equation is 3. So, order of a differential equation is actually the order of the highest derivative that is present in given equation. And degree is also evaluated as degree or power or exponent. Degree or exponent or power of the highest order differential coefficient that is present in given equation when the equation is made free from radical signs or fractional powers. Radical signs means square root, cube root, square root. All these terms are said to be radical sign. So in order to find degree of a differential equation, we have to simply first made the given equation free from fractional powers or radical signs. Suppose in this differential equation here, the order of the differential equation as first order derivative and second order derivative is present, and the order of the highest derivative is 2. Therefore, the order of this differential equation is 2. But in the case of obtaining degree of this differential equation, here the square root is involved. Square root is basically a radical sign. So in order to find the degree of this differential equation, we have to first made this equation free from this radical sign or this square root sign. So in order to remove this square root sign, we have to first shift this term into right hand side, then the equation transformed into minus square root of 1 plus dy over dx whole cube. Now To remove this radical sign, we simply have to square both the sides. When when we square both the sides, then we find this form of the differential equation: d square y over dx square whole square is equal to 1 plus dy over dx cube. Now this transformed equation is now free from radical signs and fractional powers. Therefore, now we are in the position to define its degree. Degree is defined as the power or exponent of the highest order differential coefficients when the equation is made free from radical signs or fractional powers. Therefore, the power of the highest order differential coefficient is 2. Therefore, its degree is 2. So order can be evaluated as the order of the highest derivative present in given equation, and degree is evaluated as the power or exponent of the highest order differential coefficient present in given equation when we first transformed we first transformed the given equation in an equation in which there is no radical sign or fractional powers. Now solution of a differential equation. Solution of a differential equation means any relation between the dependent variable and independent variable which should be free from the derivative or differential coefficient, and further which satisfy the given differential equation is said to be solution or integral or primitive of the differential equation. So solution means any relation between the dependent variable and independent variable which do not have any differential coefficient, and further which satisfy the given differential equation. We simply set it as a solution of that differential equation. Now types of differential equation, basically three types of solutions exist. First one is general solution, or simply said to be as solution. General solution is basically that solution in which exactly as many independent arbitrary constants should be involved as equal to the order of given differential equation, then that solution is said to be general solution. And particular solution is obtained from the general solution by putting fixed values to one or more of the parameters that are involved in general solution. And the last solution is singular solution. Singular solution is basically that solution which cannot be obtained from the general solution by any choice of the values of independent parameters or independent arbitrary constant. That solution is said to be singular solution. Suppose here we have mentioned a differential equation. As we simply solve this differential equation, then its solution can be obtained from one of the standard method, that is variable separable method. Then this solution involves exactly one parameter where C is any arbitrary constant. This solution involves one parameter, or equivalently we can say that this relation involves as many independent parameter as equal to the order of this differential equation. The order of this differential equation is 1 and its solution involves one parameter. Therefore, this solution is a general solution. General solution means basically a solution in which exactly as many parameters should be there as equal to the order of given differential equations. Now, in order to find the particular solution, we have to put some fixed values, some particular values to one or more independent parameters. Here, only one parameter is involved. If we put some fixed values to this parameter C, then we find particular solution. Suppose if we put C is equal to 0, then we obtained two particular solution. One particular solution is plus x cube by 3 raised to the power 3 by 2, and another particular solution is minus x cube by 3 raised to the power 3 by 2. Similarly, if we put c is equal to 1, then we find additional two particular solution. C is basically a arbitrary constant. We can put any value to this constant C. When we put the fixed values to C, we obtain particular solutions. So particular solution can be obtained from the general solution by giving fixed values to one or more parameters that are involved in general solution. Now, in order to find the singular solution, as it is clear that here in this differential equation dy by dx, as the differential equation is given as dy by dx is equal to xy raised to the power 1 by 3. Here, if we put y is equal to 0, as it is clear that y is equal to 0 will provide dy by dx is equal to 0. That is, left hand side is 0 when y is equal to 0. Also, right hand side is again 0 when y is equal to 0. Therefore, we can say that y is equal to 0 is a solution of this differential equation. But this y equal to 0 solution cannot be obtained from this general solution. Cannot be obtained from this general solution by any choice of the independent parameter C, as we cannot eliminate this term x square by 3 with this C, as C is a fixed parameter, so it cannot be of the form of x square by 3. So y equal to 0 solution cannot be obtained from this general solution by any choice of the independent parameters C. But still y equal to 0 satisfy this differential equation. So such type of solutions are said to be singular solutions.